Broadcast is now starting. All attendees are in listen-only mode.
Welcome, everyone. I'm Drew LaFleur. I'm the CEO of Technical Toolboxes, and want to thank you for joining us today in our latest webinar in a series. We've been doing them about once a month for the past several months. Today, we take a look at the challenges of AC-induced corrosion in pipelines. The webinar was created in collaboration with our subject matter expert, Joe Pikas. Our goal today is to provide thought leadership and cultivate interest in the profession. We'll look at the issues facing above-ground storage tank inspectors and operators, as well as underground piping. Additionally, we're promoting Technical Toolboxes software and professional development for pipeline engineers and integrity managers. So we're going to go through some technical discussion. We're going to take a look at some options for software solutions. We're going to present you with a couple of polls to get some feedback from the audience, and then we'll take questions and answers at the end. So if you would, as questions pop into your mind, if you would write them into the chat box or submit the questions, we'll have someone gathering those up and presenting them to Joe Pikas at the end. We go to the next slide. The next one, sorry. So addressing the AC challenges in the right-of-way, the heart of the challenge is recognizing and modeling corrosion induced by the proximity to high voltage power lines. These power line related issues often go unnoticed until corrosion appears, and it can be quite quick that the corrosion happens. Manual AC mitigation calculations are tedious and extremely time-consuming. Calculations are even more time-consuming and costly after the fact, and the right-of-way might not be accessible if you're going in to do a repair on a leak. So today, our expert will talk about the challenges and how Technical Toolboxes facilitates addressing them with better engineering performance. So Norlene, if you take us to the next slide, we are going to do two quick polls to help us gauge the kind of audience that we hear and help us guide our progression through the webinar. I think we can go to the next one.
Okay, give me 1 second.
Okay, there's the second of two poll questions. We'll take just a few seconds to answer that, and then we'll get on to introducing our speaker. Okay, I think we can go to the next. Our speaker today, Joe Pikas, brings more than 50 years of pipeline engineering knowledge to the conversation. During that time, he's worked in pipeline construction, operations, corrosion control, design, and implementation. He's an expert in pipeline integrity and risk, coatings, cathodic protection design, and AC mitigation. In 2009, Mr. Pikas was awarded the NACE Distinguished Service Award. He's received many other awards through his career. He's contributed to more than 50 papers to industry and trade magazines, other publications, and conferences. As a consultant and teacher for Technical Toolboxes, he's been a guiding influence on software development and instruction of corrosion-related courses. Sharing his years of work in the field is a passion for Joe Pikas, and I'm sure that you will enjoy your hour with him. With that, I will turn it over to Joe.
Thank you, Drew. I appreciate it. And next slide, please. Okay, AC Mitigation Overview. You're all here for a reason, and it's AC. It's always been a problem, as long as I could remember. And I'm gonna and when I do this introduction, I'm gonna take you back 60 years, is because officially, and the reason I say 60 years is because it was recognized on pipelines even back then. You know, the problem was recognized. And a study was done in 1965 by the American Gas Association, now PRCI. It was a 4-year study, and the company I work for happened to do this study. Isn't that nice? And that's when I got in corrosion, right at the end of the study. And I want to tell you this story because it'll give you a background of how long this problem has been around and why it's invisible. Well, we do the study, and I believe the coupons were at least an inch or greater, and they were bare except for the edges. And this is important. And out of all the data we gathered and everything else, guess what corroded? Not the coupons themselves, but the edges of the coupons that were coated with an epoxy. And lo and behold, that blew everybody away. And that's when current density, we attributed AC to current density back then. And it was interesting. We didn't have a criterion for it. We didn't know what it was. We didn't know what it took to make it happen. But it was quite interesting. And I like to tell that story because I still have that hand typewritten paper with that study on it. So that's been the problem. And we've gone through ups and downs in our people recognizing it, not recognizing it, believing it, and so on and so forth. But it's been around for a long time. In fact, it's been well over 60 years ago. But I put the term 60 because that's when the studies begin to start. Why is it an invisible threat? Well, because it was difficult to recognize at first. You know, like I say, a group of engineers recognized that the morphology was different than the normal type of DC corrosion that we're experiencing. So i.e. that was a big clue. So what are the consequences of not getting a model together? Well, they're pretty big. You run your first ILI run and you figure it out real quickly. Where did this unanticipated corrosion occur? And that's been the problem. It gets everybody. And what's even more compelling is when they put a new pipeline in, and what happens? Several pipelines have developed leaks within 6 months of installation. That's pretty sad, and this is what we're dealing with. So these are the consequences of not modeling. Even though PHMSA allows you 1 year to put CP in place, AC doesn't allow it. You've got to start very soon, like the time you're designing the pipeline. So this is why I want to bring this out. That's how important it is. So I think these are important points to remember. Modeling, what does it consist of? Well, it consists of induction, steady state induction. You know, and how do we do that? Well, we could go out in the field and take LEFs. We could do things like that. We could spend a lot of time in the field and do it manually. Or if we're smart and we want to do it right without undue field work, we could begin modeling on it. Probably the best things we could do is start taking some 3-layer soil resistivities and things of this nature. That's probably a good start. I'll skip over mitigation for a second, and then faults. Whose fault is it? That's the problem. And now with the regulators asking questions, okay, Mr. Pipeline Operator or Miss Pipeline Operator, where do you anticipate your faults now that you're in this right of way, this joint right of way with the power line? What are you doing about it? Do you know where these faults could occur? This is what modeling does. And then how do we take care of it? How do we mitigate it? Either the steady state induction or the faults. And there's all types of faults, and we'll talk about those in a few minutes. We're going to talk about developments, enhancements. This is what it's about. You've got to stay on top of what's going on in these fields. I've been a NACE member for over 50 years right now. Unfortunately, they're not going to have their conference. It's going to be remote, and so this is one of the things that I miss out on is going to all those meetings. But they will have virtual meetings, I understand. So for you folks who haven't gotten that information, I just want to pass that on. And where does technical toolboxes get in? Well, technical toolboxes has always been involved in PRCI and the distribution of software and their materials. And one of the things we've been involved with is, of course, AC Mitigation, R-string, and others. So and HDD and so on and so forth, all the way down the line. So I just want to point out, where our relationship is in that area. Multidimensional solutions. What about that? What are we talking about? What are multidimensional solutions? Well, what sets us apart from the other guys is we are involved in ArcGIS programs. And what does that mean? Well, you could tie your data integration or your integrated data right to the to the data that you're running in your models. You could mix and match it. You could compare it. You could analyze it and do all types of solutions in that area. And what is knowledge management? What do we mean by that? I got one word for that: efficiency. And what do I mean by efficiency? By the transfer of knowledge to your client, to your customers. This is what it's all about. So I just wanted to point these typical things out, that what we're going to be discussing. Next slide, please. Okay, I said it was, and the problem has been around the oil and gas industry for more than 60 years. The reason I selected 60 was because it was a magic number when I started getting involved in it. So this is why I looked at it from those original studies that were done back in the 60s. So I just wanted to point that out. And the problem in the beginning, as I said, the corrosion found on the pipelines, it's been mistaken for other causes. They didn't believe it. In fact, many of the PhDs and engineers said there's no such thing as corrosion. It can't happen. Even the PhDs indicated that it cannot happen on a pipeline. This is what we dealt with in the beginning. Since then, it's taken off. We quickly realized that it is happening, and this is how these models got developed. and it was a good thing. The persistence prevailed. Why HCAs? It doesn't have to be in a high consequence area. It could be anywhere, and this is one of the things. Now, obviously, we're going to have more higher likelihood in an HCA than we are in remote areas, but this is why we do modeling. This is the whole purpose behind it. And then we're dealing with everything else in the right of way, and I'll be showing you pictures on that in a second. But the coexistence of all of these utilities even makes it more difficult. And this is what we need to be dealing with is knowing where these utilities are located. Also, we have to keep in mind that since the installation of these AC power transmission towers, lines went in, they've been increasing their load factors significantly. Let me give you an example. We deal with some clients in Thailand. Okay, these guys are dealing with 10,000 amps on their circuits now. And I could see the day where we're going to have it because of the new cabling and stuff that has been developed recently. So these are the kind of things that we need to keep on top of. So what happens when the loads go up? Up go the AC voltages directly. It's a transformer effect. And then here's the other thing. The corridors, you know, they're a mix of everything, as we just said, but because of population densities, guess what? We're stuck with putting our pipelines going in the same corridor as the AC towers are. And of course, the land departments of many transmission companies say, yeah, this is great. Do they consult with the engineers or any of the corrosion folks or folks that are involved in any of this stuff? Maybe, and maybe not. Next slide, please. Okay, this is what I'm talking about. This is some lines, happens to be a 30-inch, a 42, and some other diameters in there, along with two high voltage transmission lines, power lines. And you could see what's going to happen quickly. This is just typical. This is up in the Northeast in New Jersey. Highway 1 is to the left, and this is just a entrance road to another road. But anyway, this is typical of what you're going to see up there. And I picked this area because this is an area I'm very familiar with. I worked up there at one time. So this is what we got to deal with. And this picture is old, so there's all new stuff in there. Those trees aren't there anymore. Everything's gone. The linking of AC, you know, in these co-located areas is a real problem. So what happens when you have 4 and 5 sets of towers paralleling 4 to 5 sets of pipelines? Not a problem. You know, it's one thing calculating one pipeline and one tower line. It's another thing calculating 10 or 11 or 12 pipes or 10 or 11, 12 power lines. My buddies in Thailand were using 31 power lines in their modeling. So try to model that. It becomes very difficult. So these are the challenges with modeling, and the challenges of not modeling is our AC corrosion, and it's been demonstrated 60 years ago, at least, you know, regarding the initial studies that were done, the official studies that were done. And then we got the thing called lightning, okay? And you all may want to write this name down, Vaisala. Vaisala is a company that studies lightning on power lines. And they could tell you how many strikes or strokes, actually if it hits ground, it's a stroke. So if it's a strike, it's cloud to cloud or something else. So, but it's a stroke if it hits something. So keep that in mind, so I don't be corrected. And the power line could experience a short circuit or a fault or an episodic upset or an interrupter or going off, which can cause an impact on the pipe or the coating. So when you have these episodic upsets occurring, and you're in proximity to those towers, which have grounds, and you're only a few feet away, i.e., you got a problem. So these are the kind of things that we're faced with on a day-to-day basis. Next slide, please. Okay. I love this lightning strike. I've written several papers on lightning. It just fascinates me because it's such a great, it's just exciting to see, Mother Nature at its finest, having these strikes in the air. But the problem is this is when we get high winds, equipment begins to fail, from contacts, whether the wires wire to wire or even something that could break, the wire breaking and making contact to ground. I've seen wrote a paper on that one too, where it made contact to ground and the issues that were found after it. And they're not pretty. So these are the kind of things, unanticipated events we need to deal with. And then it's the energy, that's transmitted between the two. And I'll use the word conductive or resistive fault. If you have a conductive or resistive fault, you are going to have some problems. And then we have inductive, and we'll talk about that later. And they're the typical ones that we usually run into. So these faults can run from very short periods of time, and still, even though it's a short period of time, be a safety hazard to the person, primarily to the personnel, and possibly to the pipeline, the coating on the pipeline, and the steel, a puncture. And this is the things we want to avoid. So this is why we get involved with. This is why we need to know in advance through our modeling what kind of conditions we could expect. Next slide, please. PRCI Mitigation Toolbox is the main engine behind the AC mitigation solutions. The AC Mitigation Power Tool is a separately licensed widget or app in the Pipeline Hub environment that uses geospatial analysis to automate and dramatically reduce the time required for the calculations and entry of distances, angles, sectioning, and other inputs. Also to streamline modeling as well as calculating new inputs such as arc, step, and touch potentials, which I mentioned in the previous slide. As you could see in this graph or plot, we have 3 pipelines. We could have 10 pipelines and we could have 10 tower lines. It doesn't make any difference. It still takes the same amount of time. This is the result is more powerful in a fraction of the time and the effort invested in modeling. Unfeasible modeling, like multiple pipes and towers, make these efforts very feasible. Next slide, please. This is that same place up in the Jersey area, and now you see a better perspective of what that right of way is, and where these 30 and 42 and this 12-inch and the fiber lines are running, and there's some other lines in there too. I don't even know half of them. I can't remember them all, but there was quite a lot. But in New Jersey, which had one of the first one-call systems in the country, they require you to box out where you're going to dig and down to the pipeline, and then also just mark where your cables or whatever else you're going to put in there. And you could see when we were putting in mitigation in this area, we were in the back of people's yards, just to let you know, to mitigate. So this is how tight it can be when you're working in these type of environments. And you could see the power line issues. You could see the houses, how close they are to the power line themselves. And I could tell you one thing about working up there. Anybody who walks on that right of way will be questioned by every landowner up there. I could tell you they keep track of everybody who goes on those right of ways, the landowners, because they are concerned about everything. That was something we found out when we worked up there doing this kind of stuff. So anyway, the key to this is yes, the program will do 3 types of mitigation. It'll do discrete, like a deep well, distributed, multiple vertical anodes or horizontal anodes, and or parallel anode or cables, whether you're using copper, zinc, or of your choice. So this is what makes it nice. And we do follow the NACE criteria and things of this nature. So I've been involved on all, the AC committees and things of that nature, along with the coding conductance committee too, which I'm still chairing. And anybody's a NACE member, we hope to have that out for ballot in about a week or so. So just to keep everybody apprised of what's going on. So don't be surprised. Look out for the coding conductance. I got to say it since I've got an audience. Next slide, please. Okay, this is our ArcGIS program, and you can see this is Jersey and at its finest. You got subdivisions. Condos on one side. You have housing on one side. About a quarter mile up from this area it's a tank farm. If you want to talk about industrial, commercial, residential, the whole 9 yards, everything was on this line in this 15 miles that we studied. And on top of that, I wrote a paper on this, a tale of 2 pipelines on AC corrosion on this particular line, because we had an old line and a new line, and the older line didn't experience any AC corrosion, and it's close to I guess, yeah, about 65 years ago. So, it was put in. So just to let you know. So integration. This is what it's about, So keep that in mind. We use the AC current density NACE criteria. We use the Barnes layer. The single. We have a choice of graphics. We can import and export data very easily, and here's the key. These most projects are in hours, not days or weeks. I could have really, and I know some people spend weeks on this stuff, and then training less than 2 hours. So the 3 things that stand out is the ArcGIS, the ease of use. Like I said, we had one guy, don't bother me, I got it. And he didn't want no training. And like I said, training less than 2 hours, down or 0 in some cases. Next slide, please. We are one of the leading providers or the leading provider of integrated desktop in engineering software for pipelines. And there's no doubt about it. We got both a desktop and cloud-based type of choices, and of course we got specialized training. We take the experts out of the industry and utilize them for the training, and we try to get the best. We also have, we also provide corrosion apps or widgets. We follow the NACE guidelines on those. We do risk integrity management, and we've been doing this for over 2 decades. We are well aware of the challenges, and this is one of the reasons why we moved to an integrated system like this, is because the worst thing in the world is when you have an audit. I'm sure there's some pipeline operators here, and you've got to come up with the information that they demand sort of right now. And the nice thing about it is when you have an integrated system like this, it's easy to compare and analyze, especially when you bring your ILI data in and other data such as close intervals and things of this nature, and combine it with design criteria, design it with crossings that are done every day, the typical stuff. So keep that in mind, that this is great stuff when you could bring it up within seconds. And then of course, it's the knowledge transfer. This is the multi-dimensional solutions that we're talking about. So we could move on this very quickly, with this type of data. And next slide. Those guys in that last picture were just doing a close interval survey. They were taking some AC potentials also at the same time. So what is knowledge? I said knowledge management is efficiency. And I mean it. I said that in the beginning. Well, it's because we're sharing our knowledge, with the other experts. This is how we learn. This is how I got started in the industry. We actually had training programs, 6-month training programs, where engineers would go 6 months on this on this group, 6 months on that group, and 6 months and 6 months and 2 years, and then you had to make a decision. And where you want to go. Well, sometimes they make a decision for you, but it's okay. And I'm glad they did for me. But anyway, so mitigation, solutions, this is what we're working to do. To work with you guys, work with the industry, so we can market tools. So when you have an ILI run, or you got a hydrostatic test, and you want to compare that to what you just did with AC mitigation. Cool, you could do that. This is the nice thing about it. We have those capabilities. You want to compare it to how many times that contractor ran over your pipeline and at these different crossings events. You could get information there, and especially if you found some anomalies that shouldn't have been there. So these are the kind of things that we're talking about. And then the neat thing about this is it connects to the engineering standards, API, NACE, and others. Where we could bring everything together. And of course ASME, how could I forget that? Integrated maps, this is what it's all about. And once you have the integrated maps, then you can do your geospatial analysis, visual reconnaissance, and bringing in existing databases and looking for disparate information and things of this nature. So within the systems. So these are the kind of things that when you have a knowledge management system, really complete the picture. Next slide, please. And of course, we're always looking forward, you know, as gas continues to replace the coal plants. Hydrogen is now being mixed, you know, the 10% mix. They're doing well over Europe, and it's starting here in the US, and the shift towards renewables and development, of course, always means more encroachment. That's a good, bad thing. And then what happens for post-COVID-19? And of course, only the smartest, the most efficient teams will survive. And this is what it's all about. And next slide. So what are we talking about? Technical toolboxes, products, and services. Well, we have software and training. We got the hub. That's our pipeline hub environment. The pipeline toolbox, and the hub includes all of this. That's an integrated data environment. And under it is the pipeline toolbox with a 250 engineering calculations for between design and operations and maintenance and everything else and in between. We're the authorized PRCI software seller. We provide the power tools to enhance the pipeline engineering, and these are our specialty tools. And so we got the general tools, and then we got the ones that, hey, these guys do this every day. You know, they want to pound out this stuff, and we call them the power tools. And then we got live training and both by webinar and classroom. So and you get your PDHs, get the credit, which is really nice. You need to go to our website, look it up. We got some training coming up, and I'll show you on the next slide what's coming up as far as AC. And next slide, please.
Hey, Joe, this is
Yes.
Drew. Let me jump in here for a minute.
Yeah.
Can we just back up one slide, please? One thing that I wanted to clarify from a little bit earlier in the presentation is that you know, AC Mitigation Power Tool that we offer is powered by PRCI's AC Mitigation Toolbox engine with some significant enhancements layered on top of it. We are an authorized reseller, but PRCI does distribute software directly to their memberships, and they do distribute and sell reports directly on their website. So if you're looking for reference material related to AC mitigation, PRCI does have some great content available on their website. If your company is a member company, of course you'll get it for free, and you probably already know this. But if you're not, they are available for purchase, and the price range is pretty significant, from fairly cheap to pretty expensive, depending upon the sophistication and demand for that particular content. Just to build on what Joe was saying, we do have a lot of courses. We are continually adding technical subject matters, and we're continually adding instructors. We have, I believe, 13 new courses this year and 5 new instructors, and we would love to hear from the folks on the call or in general about what types of training would they be interested in, or do they actually need, and we'd be happy to steer our roadmap towards the kind of feedback that we get there. Would you go to the next slide?
Okay, and thank you, Drew.
So, yeah, as Joe was saying,
yeah,
the Pipeline Hub is our new environment. It's an integrated data environment where we try and make everything talk to everything to give you a much more sophisticated picture of what's happening with stresses or corrosion processes and whatnot on your systems. Also helps you with TVC compliance. There's lots of upside to doing that. The AC Mitigation Power Tool brings the factors relating to power lines and the right-of-way into the hub. And automated work processes streamline segmentation, calculation of distances and angles, resistivities, a wide range of things. And it helps you automate the AC mitigation distance and angle calculation with your cathodic protection design. So we make Pipeline Toolbox talk directly to AC mitigation software. And when you change your cathodic protection design, the relevant things in your AC mitigation cases will update. If you would, advance the slide one more. So we're going to do a quick poll after this slide, and then we'll turn it over to the Q&A session. And Joseph is going to walk us through that. So if you have any questions, please make sure and submit them. As Joseph was talking, we do have these training events. We have cathodic protection system design February 26th, and we have an AC mitigation course in March. We have many other courses between now and then, some of them corrosion related, some of them not. But as Joe said, please do check out our website for those course offerings. You go to the next slide. This is our last little poll, and this just helps us understand how to improve. So if you would take a minute to vote on what you would like to see in a future webinar. Okay, I think you can move to the next slide. So you stick around for the Q&A session, but one of the things that we'd be happy to provide information with, and you can just chat and type into the chat box if you're interested in any of this. But what's your most meaningful next step? Is it demo? Is it reading materials on the technical side? Is it a training course? Please type in your feedback if you have any. And with that, I will turn it over to Joseph Ladner, who is an engineering performance advisor who has been keeping track of all the questions as they've been coming in, and try to get as many of these answered for you in the next 15 minutes as we can. Any that we don't get to, we will follow up afterwards via email. Joseph, the floor is yours.
Alrighty, yeah, appreciate that, Drew. Hope everyone can hear me loud and clear. First and foremost, I want to thank everyone who joined the webinar today. I think we had a little over 300. So all over the world, no matter where you're at, hope you're staying safe, but hopefully you found this to be a little bit educational. As Drew put, my name is Joseph. I'm Engineering Performance Advisor here. Some of you may know me. But nonetheless, what we want to do here, ladies and gentlemen, is start the Q&A. So if you have any questions at all, please feel free to submit those through the chat icon, and we will try to get to them here with the remaining 15 minutes that we have. But if you have attended one of our webinars in the past, we do a very good job at compiling questions and want to make sure to get back with you either with your feedback or to directly answer your question. So I'm just going to start going through all the questions, ladies and gentlemen, with the time we have remaining. There's over 25 questions submitted, so I'm gonna shoot everyone straight. We're not going to be able to get to all of them. I'm trying to organize them the best I can, but keep submitting them as they come about. A couple questions I have seen pop up that I'm going to try to consolidate into a single question is, you know, it was mentioned the AC Mitigation Power Tool several times throughout the presentation today. What all comes with it? So a couple key points for you all to be aware of. The AC Mitigation Power Tool comes with an integrated Arcgis interface for sectioning pipelines and tower locations so it can aid in the auto calculation of angles and distances. It's basically a quick modeling interface, ladies and gentlemen, for steady state faults and mitigation. On the mitigation end of the power tool, you can design your discrete anodes, your distributed anode beds, and parallel wired placement. And at the end of the day, I mean, it's really designed to report significant time savings, improvement in engineering accuracy, and field better engineering results within the AC mitigation space of pipeline engineering. So just wanted to make sure that question was asked, and hopefully that made sense for the ones that asked it. Rounding back to what Drew talked about, there's a couple questions on, can we see the software? If anyone is interested in actually seeing the software live and in person, within the chat icon, just put interested. Again, just put the word interested, submit it. You will be documented, and we'll make sure to follow up with you to either see the software, or you can either even demo it yourself for a short trial period. Again, number of questions on, I'd like to see it. So just put interested in the chat bar, and we'll make sure to follow up with you. That was kind of a number of questions consolidated into just two questions there, and hopefully I was able to answer those for everybody. I got another question, and some of these I'm going to be able to answer, and some of these I'm going to kick these over to Mr. Joe Pikas. I do have a couple I'd like to kick it over to you, Joe Pikas, if you can hear me on your end. The first, Joe, is going to be a question that pertains to what is the difference between an inductive and conductive fault? Again, what is the difference between an inductive and conductive fault?
That's a great question.
And that's for you,
Joseph.
Joe.
Yes, thank you very much. That's a great question. And the best way to answer that is conductive or resistive is true the earth, okay? They're actually both through the earth, but the one that you really need to be concerned about is the conductive, because it is the one that's going to generally where the pipe is in very close distance or proximity to the tower line or to the ground, whereas and that's usually because of the type of failure that occurs on the power line, such as a type of fault that it's an episodic upset on the power lines themselves, and the fault goes right to ground. The other ones are inductive, where it goes to what they call the shield wire, and it'll dissipate along the tower lines, and that's usually just it could be just a minor upset or lightning strike that occurred, and it travels down, and it's usually not as bad as far as power goes and damage. So the conductive or resistive faults are the ones that are going to cause the most damage, and the other ones are going to just maybe cause some personnel hazard issues. Great question.
Okay, awesome. Thank you, Joe Pikas. I got another one for you, sir. How can you come up with an estimated coating resistance on a pipeline? Again, how can you come up with an estimated coating resistance on a pipeline?
Okay, one of the other things that folks run into, of course, you could always go out and do the NACE studies and measure it and then calculate it. And of course, that takes a lot of time. We also have some tables. They've been generated over the years that help you determine approximately what the coating resistance is, because what we're looking for is an average coating resistance along the pipe, and we have tables within our user guides that'll guide. We have several tables that you could use, and they'll get you within pretty decent range, and of course it does help to know the age of the coating and things of this nature. That'll help you discern which coating resistance to use, and any type of issues they may have had it during construction too. So if it's an older one, obviously you're going to have some some more problems.
Okay. Appreciate that, Joe Pikas. Got another one here for you from another participant. So if there is above ground piping, Joe Pikas, that is running parallel to a high voltage power line, is there risk of corrosion in that application, or is it buried piping that is the corrosion concern?
It's typically the buried piping. The big thing is once it goes up above ground, you get a capacitive effect. Once it enters back into ground, that capacitive effect ends because the pipe is virtually grounded again, and now you're back into the inductive mode. So you go from a capacitive mode to an inductive mode, and we get that question asked quite a lot, and so the points that you really need to worry about is where it enters and exits. These are points of concern. So keep that in mind. And of course, if it's exposed, well, that's another thing. There's other issues, but for the most part, once capacitive, being above ground, once it enters, it becomes an inductive situation.
Okay, thank you, Joe Pikas. Again, got another one. Which one has a significant impact? The voltage of the power line or amount of amps or current that goes through the power line?
It's both, but the one that controls the voltage the most, the significant portion, is the current itself, the loading. And this is why I mentioned about the 10,000 amps that they're experiencing over in Thailand, where they're getting extreme voltages on the pipeline. Great question.
Perfect. So another question: if a pipeline is not complying with any cathodic protection criteria, or without any cathodic protection at all, is it more than likely to be affected by AC corrosion?
Well, first of all, they're in violation of the law because everything is now really almost needs to be protected. And
yep.
And second, I would say if there's very low DC current density, it does help in that sense not to be impacted by AC. So the current DC current density plays a role, and the problem is there's all kinds of studies on it. What the levels are. So I'm not saying it's not going to be impacted, but it's going to have a lesser effect. I would put it that way.
Okay, thank you, Joe Pikas. With 5 minutes left, I want to try to get a couple more questions in. So I got a question for you, Joe Pikas, back to the models or the AC Mitigation Power Tool. So what would happen when you have a combination of above ground and underground pipelines? Would the model acknowledge the possibility of corrosion through the support of the pipe when it is above ground? So you have a combination of the two. How would the model treat it?
The model will treat it as obviously it's not going to calculate the voltage on the above ground portion because it's a capacitive effect, but it will calculate the current, the induced current through that section. So if you're putting the right inputs in there, you'll get the right voltages. I mean, you'll get the right results. The other thing you need to consider is the above ground. You're going to have, what are you going to put for soil resistivity? Well, if you're going to use the soil resistivity of air, right, it'll give you higher voltage, similar to what you would experience on a capacitive calculation. It's not going to be the same, obviously, but the inductive current portion will be correct in the calculations. And obviously, what we're looking at for the purpose of the program is where it goes underground. But it will not preclude the results of going above ground if it's done correctly.
Okay. Thank you, Joe Pikas. I got a couple questions pertaining to this, Joe. You know, some users have asked, we have utilized AC mitigation modeling via other third-party platforms. What separates the AC mitigation power tool based on your industry experience from others out there?
Okay. We'll start with cost, number one. Number two is ease of operation. Number three is the ability to do the work in hours versus days or weeks. And that's the difference. And one last one, it's intuitive and you could easily be trained on it.
Okay. Appreciate that, Joe Pikas. Let's see, we have time for maybe one or two more.
Yeah.
Again, just to be honest, everyone, we're not going to be able to get to all the questions. There's quite a bit on here, but we definitely will follow up with you if your question wasn't answered. Another question: can AC corrosion happen if the power line is buried next to the pipeline?
Generally, if it's bundled, it doesn't happen because they put an outer shield on there, and that bundle is intertwined, so the effects cancel each other. And this is the reason why, if you look at your tower line and look at the way the phases are separated, each phase wire, it's always the closest phase that impacts you. Where in a bundle, it's wrapped around, and then it has a ground wrapped around it. So the likelihood of that being a problem is going to be very low. Now, it could fault, but the likelihood of AC corrosion is going to be minimal or nothing.
All righty, appreciate that, Joe Pikas. Again, for everyone on the webinar today, we appreciate everyone that's come. If we have not addressed your question, I really do apologize. Just for the sake of time, I see there's probably a dozen, if not more, that were left unanswered, but we will get back to you. Last but not least, if you are interested in seeing or seeing any of the software, just please put interested in the comment question there, and we will make sure to follow up with you. We will be putting this recording on our site, and you'll be able to view this later. But nonetheless, hopefully you all found this webinar to be beneficial. Hopefully you learned something today, and hopefully you'll learn a little bit more about some AC modeling software that is out there for you, you know, if that is a concern that you need to address. Again, you know, our AC mitigation power tool, at the end of the day, it's a huge time saver, improves the accuracy of your AC mitigation modeling, and it's going to field better results. So at the end of the day, everyone, appreciate it. We will be having other webinars coming up throughout 2021, Q1, Q2. Be looking out for those. We appreciate your feedback. Hopefully you found it to be beneficial, and look forward to seeing you all again. Thank you.